All right, let's dive right in because today's explainer covers a topic that is absolutely exploding right now: AI agents. If you've been paying any attention to the world of artificial intelligence lately, you already know that agents are the frontier. We're talking about the literal difference between a chatbot that just talks to you and a digital worker that actually goes out and gets things done. But what actually makes an agent tick? Well, today we're going to break down this highly complex architecture into 3 universally relatable components. By the time we wrap up, you're going to have a crystal clear mental model of exactly how these incredibly sophisticated systems are built from the ground up. To really wrap our heads around this, we have to start with a fundamental question. How does AI actually do things? I mean, we all know standard language models, right? Your typical chatbots. They are fantastic at generating text. You give them a prompt, and boom, they write you an essay, a poem, a Python script, but they're trapped in a chat box. They can't actually go out and book a flight for you or update your company database or send an email on your behalf. They just talk. Autonomous agents, on the other hand, take action. They bridge that massive gap between just spitting out text and actually operating in the real world. So, how do we bridge that gap? Well, every single agent system, no matter how ridiculously complex it seems, boils down to this simple biological metaphor. We've got 3 core components on the agenda today. Number 1, the brain, powered by the LLM. Number 2, the hands, which are the tools. And number 3, the nervous system, which is the orchestration loop.
Let's start with component number 1, the brain, also known as the large language model, which is the reasoning engine.
Inside an agent, the LLM isn't just sitting there writing text. It's practically a busy middle manager. It starts by understanding exactly what the user wants, plans out the necessary steps to achieve that goal, and then actually chooses which tools to use and what data to feed them. Once those tools do their thing, the brain steps back in, interprets the results, and figures out the final answer. And what's absolutely wild about this setup is the flexibility. You can take the exact same LLM, plug it into completely different agents with completely different tools, and it just works. No retraining needed, you swap the tools, and the brain adapts.
But here's the catch for developers. Choosing the right brain is a massive trade-off problem. You're constantly balancing capability, cost, and latency. The model obviously needs incredible reasoning ability to handle multi-step tasks, and it has to follow instructions perfectly so it doesn't break character. Now, some of the newer models from folks like OpenAI and Anthropic have built-in chain-of-thought reasoning, making them super capable. But remember, every single time the agent thinks about its next move, that is an API call. And those pennies, they add up incredibly fast. Because of that, we're seeing clever engineering teams use a 2-tier approach. They'll use a cheaper, super fast model for basic routing decisions and save the massive, expensive model purely for the heavy lifting.
There's also another huge factor here. Agents accumulate context fast, like incredibly fast. Every single thought, every action, every observation gets slammed directly into the prompt. Think of it like human short-term memory. If the context window isn't massive, the agent literally develops amnesia halfway through booking your flight. So a massive context window isn't just some nice-to-have feature. It is absolutely vital so the agent doesn't completely lose the plot during a complex task.
Okay, so we've got our brilliant brain, but a brain without hands is kind of stuck. That brings us to component number 2, the hands, representing the agent's real-world capabilities.
This is where the magic happens, folks. Tools are what transform an AI from a simple text generator into an active participant in reality. Without tools, your AI is literally just an armchair philosopher. But give it hands, and suddenly it can query your private databases, call external web APIs, and execute raw code. It stops just thinking, and it starts doing.
So how does this play out in the real world? Let's walk through a quick example. Let's say you ask an agent, "Hey, what's the weather like in Paris?" Step 1, the agent software looks at its toolbox and describes the available tools, like a weather API, to the LLM using JSON schemas. Step 2, the LLM looks at that toolbox, realizes it needs the weather tool, and generates a structured request asking for Paris weather. Step 3, the agent application takes that request, validates it, and actually hits the weather API. Finally, step 4, the agent gets the temperature back, hands it to the LLM as an observation, and the brain decides what to do next.
Now, I really want to pause and emphasize something absolutely crucial here. The LLM never executes the code itself, ever. All it does is generate a polite, structured request asking to call a tool. It's the agent code, the software wrapper around the brain, that actually executes the action. This is a massive security boundary. The brain makes the decisions, for sure, but the agent code is the only thing that actually touches your systems or the outside world.
And speaking of tools, the way we build these hands is going through a massive evolution right now. You're probably going to start hearing a lot about the Model Context Protocol, or MCP. It's a brand new standard from Anthropic, and the whole point is to universally define how tools interface across different LLMs. Instead of hard-coding custom tools for every single different AI brain out there, MCP standardizes the communication. It's a real game changer for making things cleaner and universally compatible.
So we have the brain to reason and the hands to act. But how do they coordinate? That brings us to our third and final component, the nervous system, or the orchestration loop.
The loop is really where the engineering heavy lifting lives. It manages the entire execution cycle. It's juggling short-term working memory, pulling in long-term knowledge, routing the right tools, and acting as a state machine so the agent doesn't get stuck in some endless, repetitive loop. It applies structured reasoning strategies to break down huge goals, deciding when to push forward, when to pause, or when to stop entirely. And maybe most importantly, this is where the guardrails live. If the model tries anything unsafe or weird, the nervous system overrides it.
A really great way to think about this is to view the loop as the operating system for the agent. If you've ever built a web app, you know about the controller, the code that routes incoming HTTP requests. The orchestration layer is exactly like that, but instead of web traffic, it's routing reasoning steps and tool calls. It's the vital infrastructure keeping the whole train on the tracks.
Ultimately, the loop is the conductor of the entire agentic symphony. It decides when to reason, which tools to call, and how the results from those tools shape the very next move. The brain, the hands, and the loop, these three components harmonize perfectly to create systems that don't just chat with us, but actually do real work on our behalf.
Which leaves us with this one final thought. We spent the last couple of years just absolutely marveling at what an AI brain can write or draw on a screen. But we are officially entering the era of action. So what happens to our businesses, our workflows, and our daily lives when we successfully give this immense intelligence both hands to act and a central nervous system to relentlessly pursue goals? That is the true promise of AI agents. Thank you so much for joining me on this explainer, and I hope this gives you a powerful new lens for looking at the future of AI.